All right, so 14, we ended with 80 grams of dicarbon dihydride. So what is the molar mass of carbon carbide? We're just going to add calcium carbide. We're just going to add 1 part calcium to 2 parts carbon.
Is there a difference between 2Cl2 and 4Cl?
Yeah.
Oh.
I mean, it's the same number of chlorines, but like Cl2 means that it's actually a chlorine gas and it can exist by itself.
And if it just says chlorine.
If it's just chlorine, then that means it has to be Cl2. Yeah, did you? I don't know if I checked that on yours. Okay. So have no fear of ice cold beverages. Remember, any of those, when they're by themselves, there has to be a 2 behind it. Mm-hmm.
If it just is chlorine, I would just assume that it's...
Just don't think there is.
Well, I guess when C leads off with how many moles of Cl2 gas are present. Maybe would have been
All right, so did we get 64.1 grams of calcium carbide per mole there? So how many grams of calcium carbide are needed to react completely? For some reason I switched it up here, but my yellow here is showing our given quantity is 490.0.
grams per mole. Grams per mole.
Do we think we got this one? All right, so what has to go on bottom, guys? This first conversion factor needs what for a unit on bottom? Yeah, moles of H2O. Okay, so MOL H2O. Now, if we want to go from H2O to calcium carbide, so this time I'm going from H2O to calcium carbide. So I know there's 2 moles of H2O for every 1 mole of calcium carbide, 2 moles of H2O for every 1 mole of calcium carbide. That means our moles of H2O cross off, and they actually wanted us to get to grams, so now we need to use the only thing we know about mass and moles of a substance, and it's the molar mass they had you find in the previous problem. And it's that if you have 1 mole of calcium carbide, you have 64.1 grams of calcium carbide. Okay, moles of calcium carbide cross off, and I'm in grams, which is where I wanted to be. So I'm going to just multiply by what's on top. So take your given quantity. Sometimes kids forget to type their given quantity in their calculator first. So remember, start with 490. If you take it times 1, it won't change it. So let's divide by 2. And I like to enter so I have less chance for error. Times 64.1. So you guys get a rather large number. Should make sense if we take nearly 500 times over 60. So our given quantity had 4 sig figs. So we're going to look at our calculator here and we go 1, 2, 3, 4. It's a 0, and then we look to the right, it's going to stay where it's at. So we're going to round to 15,700 basically. I'm going to write it as a standard notation first. Okay, but in scientific notation, one thing I noticed on that last exam is it's something we're not all experts in yet. Okay, so remember, we're going to move the decimal 1, 2, 3, 4 times. So we get 1.57. We need 4 sig figs, so I have to put a 0, times 10, and I went 1, 2, 3, 4 places. And then remember, put your unit right behind that. That whole number, the 10 to the 4th included, is part of your numerical value. Calcium carbide.
Moles of CO2. Or CO2. Yeah.
How'd that one go? Did we do it?
I used that.
Good,
instead of
good.
that.
All right, now the next one below, they're going to start with mass. Okay, so same thing, but this time instead of starting with moles, they're going to start with mass.
Same thing. You're
So it's
just
very,
finding
very
the
similar
difference.
process. Okay, so go ahead and try
More than that.
the next section here.
Carbon. So 15.9.
It says, what is the given above? Same as
Use the
before.
same molar mass.
It's 79.
Yeah.
You have to put it in there. It's one of each. One over one cell. But it'll help you cross out everything.
So then this one's just, this is literally 1.25 divided by 79.874.
No.
Just make sure when you write your given,
1.25
you also put your
divided by
unit.
1.01.
Because remember, that tells you what your first conversion factor needs to have. Okay, so the number and the unit.
It's the same exact problem as the last one we did, just with a different.
Why are you dividing by 1? Yeah, because you but you don't do the times 2. You should divide by. You get 0.015.
0.015, yeah. So it'd be 0.0156. You get 0.0156.
Notice when they're doing their molar mass, they're using an abbreviated number. Use ours. Use what our periodic table is. I'll have our table's values on my answer key.
You said you don't care if we write in scientific notation.
Oh, if it's a very large number, I want it in scientific notation.
What about 0.0156?
I would put that in scientific notation, yeah. But evidence of that reaction tells me we really need some practice on that.
It's just so much easier to write it than the decimal.
At some point, it'll be easier to do scientific notation because math and double checking and just writing it will be second nature. The more you do it.
I did. You like it too?
What? I said same thing as model 1 with one extra step.
Well,
It's
not
summarizing it.
It's not clear the first sentence. Just put a period.
And then I said going from
Do
one
we need
ratio
to summarize? What do you
Yeah, guys, I think it'd be good for you because when you try to do this without this packet, that's probably where you're going to look, right? Like what you're doing in that step is actually taking the moles of a substance, utilizing molar ratios to get 2 moles of a different substance within a balanced chemical equation, and then going from moles of that substance to its mass, utilizing the molar mass of that.
Pretty much.
Can we repeat? Yeah, I got it.
You got it?
Turns. See if you understand it, it might be easier. You got this. You got this.
Oh, here.
Here we go. The next one's just one more step.
Volume? You're in
Yeah.
4?
We're on 3.
All 3. Yeah, mass to mass. So you go mass to moles, moles to moles, moles to mass. All right, so when we are going from moles of H2 back to what they wanted, which would be grams of ammonia, we know that we have to get from one part of an equation to the other, so we're going to go from moles of hydrogen to moles of ammonia. Then our moles of hydrogen cross off, so then we're going to get from moles of ammonia to mass of ammonia. And the only thing that you ever know about a mass is the molar mass. Okay, so 1 mole of NH3, we're going to use the molar mass that we already found, which was 17.247 grams. Now our moles of ammonia cross off, and we're in grams of ammonia, and that's how we know we're done. Now we're just going to multiply by what's on top and divide by what's on bottom, and then round to 3 sig figs. So 3.06 times 2, and I like to hit enter each time, like I said. It keeps me from fat fingering too terribly much. Divide by 1 will not change it, so 35.2 grams of ammonia, or nitrogen trihydride. Oh, thank you. Very well could be. Did I still fat finger it anyways? 3.06 times 2 divided by 3. My mass, is that what's wrong, or is my final number? Oh, okay. Very well could be here. 14.007 plus 3 times 1.008, 17.031. Oh, that they used in the problem. Yeah, I just used ours just so we could use the same periodic table. But I do think I screwed up the mass here, didn't I? Isn't it 031 if we use ours? Yeah. This should be 031. Okay, so 031 times 3.06 times 2 divided by 3. So 34.7, is that what we got?
Not that hard. Well, it looks hard. Just the way they wrote it.
All right,
Are you the 29 maybe?
34.7. I used our periodic table, so it should be close to their answers. They have very, very rounded numbers, if you notice for theirs. So I figured we'll just keep using ours, that way we're in that practice. It should be close, so I should have been like, well, crud, that's really off. I must have screwed something up. Thank you, McKenna. All right, let's look at this one. They again use that same equation, which is nice. They want to know the molar mass of O2, so it's 15.999 times 2.
Really?
All right, how many moles of diphosphorus pentoxide are formed from 3.4 grams of O2? So we are starting with this and going to this. So we're just adding one step each time, each model. But this time we're just literally just flipping it around. So we're doing the same number of steps this time, but the new step is, flip it. Okay, so we're going to start with grams. So we're going to start with 3.4 grams of O2. Draw our train tracks. If anybody wants rulers, there are some back there behind that, or they're in that brown cabinet. Sometimes I get too hung up on my line being crooked that I screw up, because that's all I can think about. All right, OCD sucks. All right, I know I need grams of O2 on bottom, and anytime you're going from one part of a chemical equation to another, you have to get to moles. Think of it as like the bridge to the other part of the recipes. Okay, the only thing you know that relates them is the balanced chemical equation. So I'm going from O2 to diphosphorus pentoxide. Now, a lot of times kids are going to phosphorus, but remember, you go to the one that's exactly like the one they're asking in the problem. Okay, so they want diphosphorus pentoxide, so I'm going to go to diphosphorus pentoxide. The only reason you would go there is if they said 2-phosphorus. Okay, that's how they would ask about that one. So I know I have to have grams of O2 on bottom, and I know that there are 31.998 grams of O2 in 1 mole of O2. Okay, so grams of O2 cross off, and I'm in moles of O2. Now this is where I get to that mole bridge. This is where I can actually use that balanced chemical equation. And I know for every 5 moles of O2, I have 2 moles of diphosphorus pentoxide. All right, so all right, so moles of O2 cross off, and I'm in moles of diphosphorus pentoxide, which is where I wanted to go. Now, the next step for the next model, guys, is you just add another bracket, and you can go from moles of diphosphorus pentoxide to mass, just by using the next moment mass. Okay, so the next model isn't any harder, it's just doing the same thing with one more step of the same thing. But because we are in the unit they already want us to get to, we are done, and we can just type this into our calculator and round it to 2 sig figs. So 3.4 divided by 31.998 times 2 divided by 5. And we have a decimal. So sometimes sig figs can trick people with decimals. Remember, we go to the first significant digit, 4, and then the second is where we're rounding, 2. We look to the right, we're going to round up. So I'm going to write it in standard notation first. So 0.043 moles of diphosphorus pentoxide, but I would prefer this in scientific notation. 4.3 times 10 to the 1, 2, negative 2 moles of diphosphorus pentoxide. Alright, now the next one is a different kind of fun. Have we all looked at it and tried it? Yeah?
I don't know where to go from, I don't know which one's the product and which one's the reactions.
Okay, and this one does take a little bit of breaking down and realizing that when they say extracted, that means you're taking it from this. Okay, so it's pulled out. Extracted is like pulling out. You're making it by this. Alright, so it says titanium is the transition metal used in many alloys because it's extremely strong and lightweight. Titanium tetrachloride is extracted from. So it's made from, making that a product. Okay, so it is being produced from titanium 4 oxide using chlorine and coke, which is carbon. Okay, carbon dioxide is also produced. It is a byproduct of a lot of chemical reactions. Oh, I colored that the wrong color there. Okay, so my pink are my products, my yellow are my reactants. Okay, so give it a shot. I'm gonna pause. I'm gonna get to that point where it's hard. See what it is and puts up.
This is just from the
Yeah. Yeah, yeah.
No, this is
And then tension is what? 4, 3. Yep. Oh, the only thing is chlorine. Anytime chlorine is by itself, what's it do? Remember, half of your advice cold beverages, the cold is for chlorine. Anytime chlorine by itself is just like hydrogen and oxygen. It's Cl2 when it's by itself. Also on your periodic table, guys, those are on there. It says diatomic elements at the bottom of your periodic table. What that means is any of those, when they're by themselves, it'd be Cr2, Cl2, F2, H, I2, O2, N2. How would you write under cocaine? So what is tetra? 4. Yeah.
Just trying to tell him what did I do. Didn't do any math.
All right, so it says these are reactants and those are the products. So we have titanium 4 oxide, which means titanium has a 4+ charge and oxide has a 2-. So it's going to take 2 oxides to get that net charge to 0. Okay? So you'll have 4 minus 2 minus 2. Okay, and you're going to add chlorine gas, which is Cl2, and coke, which is just carbon. And it's going to produce titanium tetrachloride, and carbon dioxide is also a byproduct. Here is what's at stake. Go ahead and try balance that. The one spot I didn't really put enough room. All right, there's the balance. 1, 2, 1, 1, 1. You should be able to finish the remainder of this page by tomorrow. Okay, and then tomorrow we're going to finish the packet.
Can I use the bathroom? Thank you.
There was a bell ringer yesterday, guys, so why don't you go ahead and do that if you did not do it yesterday. Guys, there's a bell ringer, and then we're going to jump in and finish what we were doing yesterday. It was the one from yesterday. Not many did it. Yep. So if you already did it, you're good. You can just jump into your packet.
What's this?
I'm recording a video for chemistry.
What's going on with the Wi-Fi in this room?
I don't know. I haven't used it yet. I've been teaching.
My friend is not here.
Because there was like 3 people that tried to call me.
Oh.
Whoa.
Again, you should be doing your bell ringer and then getting your packet out to complete where you left off. Remember, today you have to get through all of that data table section that we were working on. Guys, FYI, I am recording my screen right now and it might pick up your audio. Just heads up. There was one from yesterday, yep. So if you've already done it, you're fine. Otherwise, go ahead and do that. I just didn't remind you to do it yesterday, so. Yeah, don't take a ton of time doing it, but like with something interesting or